Section 1.1 is on connecting words and, or, and not. Those are the connecting words. The connecting words are and, or, not. Three connecting words we're looking at. Okay, and this all starts us off in a branch of mathematics which is called set theory. And what set theory is, it's the mathematical study of collections of objects. So that doesn't sound too profound, I suppose, but believe it or not, set theory is one of the most important areas of mathematics. In fact, it's often looked upon as an aspect of math that can be used as the foundation of math. Like, you could use set theory to basically prove everything else. I mean, I don't care how varied it is in math, it could all go back to set theory. And one of the unique things about set theory is, for most areas of mathematics, they kind of arose through lots of people working in different parts of the world, right? It was a slow process involving lots and lots of people. But this isn't the way it worked with set theory. With set theory, it was all created by one man. One guy came up with this concept of set theory, and here he is. What a handsome devil. This guy's name is George, with no E at the end. I've never really understood how to say that properly, but I know his last name is Cantor, George Cantor. And this guy lived a somewhat tragic life. He was German, and he was the one that came up with this idea of set theory, and he did this when he was studying infinity. He's the man who's basically responsible for most of the mathematics to do with infinity. And as you can imagine, this is a bit of a mind boggler for a lot of people. Some of the ideas he came up with around infinity. For example, one of the things he came up with was that infinity is not always the same size. There's different sizes of infinity. Some are bigger than others. Well, needless to say, when he came out with this, some people were very confused and some were very upset. It didn't seem rational, reasonable, understandable. And so he was, in his mind, he was publicly humiliated by leading mathematicians of the time. Now this is very hard for him, especially because in his mind, being a very religious man, he thought that his ideas of infinity were communicated to him through God. So now God's telling him one thing, and all these other people, leading mathematicians, are telling him that he's wrong, and this kind of caused a personal crisis in Mr. Cantor, and actually led him to become quite depressed, and he ended up in a sanitarium, a loony bin, on a number of occasions. So he turned away from math for a while because he was so depressed, and what he worked on was actually English literature. And he wanted to try to prove that Francis Bacon, another philosopher, that Francis Bacon was actually responsible for most of Shakespeare's written work, if not all of it. So pretty out there idea, which I think most people do not think is true. So he was the one who came up with set theory. That was in 1874. He was rejected. He ended up being depressed through most of his rest of his life. He ended up passing away in a sanitarium, bad health. I think he was close to penniless. A very sad story. However, since he died, he's now looked upon as one of the greatest mathematicians of all time. He's received the highest honors that anyone can receive. So he's truly one of the big shots in the history of mathematics. All right, let's get into it here. So in set theory, there's all sorts of terminology. We're going to actually do a lot more terminology next day. But today we'll start with statements. And what statements are, it's a sentence that has a truth value. In other words, it's either true or it's false. So if I say something like King George is in the West End, is that something that's either true or false? Yeah, it is. This is a statement. Is it a true statement or a false statement? It's a true statement, right? It's true that King George is in the West End of Vancouver. I mean, I suppose you could say, well, West End of what? But I'm intending to say here, is King George in the West End of Vancouver? Yes, it is. This is a true statement. Mr. Wadge teaches Spanish. No, I don't teach Spanish. So does that mean it's not a statement? No, it is a statement. Right? It does have a truth value, but in this case the truth value isn't true. The truth value is false. So this is a false statement. How about this? Baseball is the best sport. Now I know you're all like me and you're all saying it's true, it's a true statement. No, this is just an opinion. And an opinion is not a statement. An opinion is an opinion. So baseball is the best sport is not a statement. This is an opinion. Okay, the negation of a statement. If you negate something, what do? It's like you deny it. You say no to it. And that leads us to what negation of a statement is. It's the exact opposite of the statement. So it often involves the word not, and either the statement or its negation is true. One's true, one's false. Okay? It's impossible for them both to be true. It's impossible for them both to be false. One's always true, one's always false. So here's a statement. This is, definitely is a statement. Mr. Wodge is a rhinoceros. This is a statement. It's a somewhat ludicrous statement, but it's a false statement, right? So this is false. Now, what's the negation of this statement? The negation of this statement is Mr. Wodge is not a rhinoceros. This is the negation of our original statement. This statement is true. I am not a rhinoceros. Sadly, I'm not a rhinoceros. That'd be so cool to walk around all day thinking, wow, I'm a rhinoceros. But I can't do that. So you'll notice that one is false and one is true. This is always going to be the case with statements and negations of statements. One's false, one's true. The first one could be false, right? What if my first statement was this? Mr. Wodge is not a rhinoceros. Then my negation would be Mr. Wodge is not a rhinoceros, which is the same as Mr. Wodge is a rhinoceros. Okay, so this is the negation here that we're interested in. Okay, now we come to a tricky one. The statement is, all teachers love summertime. Now, is this true? Is this false? I don't know. Maybe it's true that every single teacher in the world loves summertime. But it's probably not true, actually. There's probably at least one teacher that, has a terrible home life and it's like, oh no, I'm stuck at home now. So it's probably false. But even if we can't tell whether it's true or false, it's definitely a statement because, it's either true or false, even if we can't figure out whether it's true or false. It's kind of like the statement, there are aliens on other planets, intelligent life forms on other planets. Well, that's a statement. It's either true or false. We don't know at this point in time whether it's true or false, but it is a statement because it either is true or false. That's kind of like this one, but it probably is false. So what's the negation of this? All right, well, this is actually difficult. There's two possibilities I think most people come up with. They either think not all teachers love summertime, or they think all teachers do not love summertime. This gets confusing, doesn't it? You're probably, some of you thinking, well, it's pretty much the same thing, but it's not. This is the negation. This is the correct answer here. Not all teachers love summertime. This one's saying all teachers love summertime. This one's saying not all teachers love summertime. Why isn't this one here? Why is this not the negation? Because it's possible in this first case here for it to be false, and this one also to be false. Right? Think of it this way. If this statement here, all teachers love summertime, is false, if there is at least one teacher who hates summertime, then this one has to be true. Not all teachers love summertime. But if this one is true, all teachers love summertime, then this one's false, that not all teachers love summertime, right? You have to read that over a couple times and think about it. But for these two, the statement here and this potential negation here, it's not the negation, they could both be false. I guess I put could both be false. Let's figure that out. Why could they both be false? Well, all teachers love summertime. That could be false if even one teacher doesn't love summertime. So let's say that me, Mr. Wodge, I hate summertime because I don't get to spend time with my wonderful students. So if this is true that Mr. Wodge hates summertime, then this statement here is false. Is it possible for Mr. Wodge to hate summertime, which makes this statement here false, and also for it to be false that all teachers do not love summertime? Yeah, all I've said here is that one crazy guy, Mr. Wodge, does not love summertime. But maybe, every other teacher or maybe even 3 other teachers do love summertime. So then this one would be false as well. Can you see that? They could both be false. This one could be false because Mr. Wodge hates summertime or a whole bunch of teachers hate summertime. And this one could also be false because a whole bunch of teachers do love summertime. And remember, our rule is that the statement, all teachers love summertime, and the negation, not all teachers love summertime, one has to be true and one has to be false. So you do have to be careful with these. I know at first it's like, this is the easiest thing ever. You just throw not in front of it. But sometimes it's important where you put the not. Okay, moving on. Compound statements. A compound statement is formed by combining two or more statements. Now, when you combine statements, there's two different ways to do that. One's with a conjunction. A conjunction uses the word and. So, it's only true, a conjunction is only true if both, or all, if there's more than two statements you're combining, if both of them or all of the statements are true. So here's a conjunction. Water is wet and, right, there's the key word, and pigs can fly. So, is this true? No, this is not true. This is false. How come? Because one of the statements is false. One of the statements is false. Which statement is false? This one, pigs can fly. This one's true, water is wet, yeah. But in a conjunction, they both have to be true, and this one's false. One statement true, one statement false, means that the whole conjunction is false. One of the statements is false. Okay, in a disjunction uses the word or. And in math, or is always meant in the inclusive sense. It's a bit confusing again. In spoken English, or is often exclusive. So what's the difference between inclusive and exclusive? Basically, exclusive means it could be one or the other, but not both. So, for example, if I said something like, I'll wear shorts or pants. Okay, this is an exclusive use of or, because I'm not going to wear shorts and pants at the same time, right? I'm either going to wear shorts or I'm going to wear pants, but there's no way I'm wearing shorts and pants at the same time. With an inclusive sense of or, it could be one or the other or both, and that's a little unique, but that's the way it works. And we do use that also in spoken English. If I said something like, I'll wear my tie or hat. So someone says, you getting dressed up tonight? Yeah, I am. I'm definitely going to wear my tie or hat. And then you show up with both the tie and the hat on, then, you know, that was an inclusive use of or. You meant that you would either wear the tie, or you'd use the hat, or you'd wear both. And in this case, you did wear both. Okay, and in math, we always mean it in the inclusive sense. So it could be one, it could be the other, or it could be both. So, water is wet or pigs can fly. Remember, this statement is true, this statement is false. So is the whole disjunction a true statement? Yeah, this is true. As long as one of them is true, then it's true. If both of them are true, it's also true. The only way it's false is if both statements are false. Alright, last question here. List the numbers from 10 to 25 inclusive that are, inclusive means? It means including 10, including 25, that are even. Well, the even numbers from 10 to 25 inclusive are 10, 12, 14, 16, 18, 20, 22, and 24. List the numbers from 10 to 25 that are prime. 11's prime, 13's prime, 17's prime, 19's prime, 23's prime. You know what prime is, right? Numbers that can only be divided by 1 and themselves. 10 is not prime because 1 and 10 go into 10, but also 2 and 5 go into 10. Okay, even and prime. So if it's even and prime, they have to show up in this first list, be even, and they also have to show up in this second list, be prime. So how many numbers are even and prime? How many numbers show up in both lists? None. There's none. So what you would say is no solution or no answer or something like this, or you put this. This means the empty set. Remember, I think we've talked about that before, the empty set. We're going to be talking more about the empty set next time. And next time we might have it looking like this. Look, there's a set with nothing in it. Anyway, don't get confused. We'll talk about that next time. Okay, how about list the numbers that are even or prime? So that means they could be even, they could be prime, or they could be both. So we have to list all of these. So it would be 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 22, 23, and 24. Those numbers are even or they're prime. Okay, now we're looking for numbers that are even and a multiple of 5. So that means they have to be even, they have to show up in this list up here, they have to be part of that list, and they have to be a multiple of 5. So you're not going to list all those numbers. You're only going to list those numbers that are also a multiple of 5. Which numbers are multiple of 5? 10 is a multiple of 5. 12, no. 14, no. 16, no. 18, no. 20. 20 is a multiple of 5. And that's it. So those are our numbers, 10 and 20. Okay, whoever thought those small little words, and, or, and not, could be so confusing at times? Welcome to the strange and wonderful world of set theory.
How could something so fair be so